about some of the challenges that we have to face now as farmers in terms of trying to understand the environmental impact of production systems, understand how we can stack the benefits that come from farming and the way that we farm and all those sort of things. And there's 3 projects that I'm just going to quickly touch on today, some of which you'll be able to see. So the Herbal Lake project you'll be able to see as you go around, and as I say, some of the other bits that we've been doing. So firstly, just talking about the soil carbon project, and apologies for the huge numbers of logos there. For those of you that have sat through presentations like this before, that means it's European funded. So I have got to do all that. But the soil carbon project is a really exciting and innovative project that has started down here in Cornwall. So when we talk about some of the research that goes on all over the place, this project was developed and has started down here and is really a good opportunity. And for those of you that have been sat in a soil pit, as I have been for about the last 4 months, even then, you still can't fail to have noticed the fact that there is a lot more attention and there is a lot more interest in the environmental impact of agriculture, in greenhouse gas emissions from farming. Should we, our livestock good, our livestock bad? All of this has been thrown up in the air and has left us all thinking, how do we respond to some of these challenges? You know, is grass-fed better than grain? You know, all these questions that we're having to start to understand as an industry. And a big part of that discussion is around soil carbon. Does soil hold carbon in the soil? How much? What can we do? And policy is still quite uncertain on this, and this was a bit of research that came out last year saying that there is still uncertainty regarding how much, for how long, all these sort of things, to use soil carbon as a major strategy to suck carbon dioxide out of the atmosphere and hold it in our soils. However, if you go out and talk to farmers that are on the regenerative, have been farming regeneratively or have been doing these sort of things, they'll say, well, yeah, we know our soils are better, we know they're holding more water, we know they've got more biological activity, we're growing better crops. When the climate throws all sorts of things at us, our systems are more resilient. And so you've got that on one side, and you talk, as I say, talking to some of those farmers, you say, okay, that's brilliant, it's amazing. Did you baseline it before you started? No, I didn't. Well, why didn't you baseline? Well, some of the tests are a bit rubbish, I don't know what we're supposed to be doing. So it was sort of these things that came together in order to sort of try and inform this project in terms of soil carbon. And what it meant we needed that information, that knowledge from the farmers, and a few ways of trying to test these things on the ground, and hence the soil carbon project was born. So what are we actually doing? We're trying to decide on what the best way is that we should be measuring soil carbon. How do we measure it? Is it just organic matter? Is it what the test? All this sort of thing. And then we're also looking at the relationship between soil organic matter and those proxy measures. So how often do we need to test using the lab, or can we go out and dig for worms? Can we look at infiltration? Can we look at biological activity? And is there a relationship between that soil carbon content and some of those proxy measures? So if you potentially don't want to go and do lab analysis, what are the best tests for looking at how healthy and how much carbon your soil is holding? Then, as Chris was saying, and to say, how do we look at how that soil carbon impacts in terms of the whole farm greenhouse gas footprints? So how much carbon is your soil holding? Is that offsetting what you're emitting as a business, and how it all works? And then what are those management practices that are beneficial in terms of building soil carbon? These are all the sort of things we're looking at. So we're working with a range of farmers. We've got 60 test sites up and down England. We've got a focus in Cornwall because we got some of the money to do a bit of extra work in Cornwall. But they are incredibly valuable knowledge holders in the system. I'm getting my head around how all the sort of lab processes work and all the rest of it, but each of our farmers are an expert in what happens on their farm. So it's bringing those 2 bits of knowledge together to try and see what works is really exciting. We have a range of farming systems, soil types, management systems, hopefully spanning most of the ones we need. And that allows us to look at what happens across all the different opportunities that we have. What are we testing? So we're testing soil organic matter, looking at what's going on down the depth of the soil profile, so 0 to 10 centimetres, 10 to 30 centimetres, and then 30 to 15 centimetres, using GPS log points across the field. So still walking Ws as we do for normal nutrient samples, but GPS logging those points so that hopefully we can go back to those same points year on year, so as to avoid any in-field variation. We're also looking at bulk density, so how tightly packed together the soil is, because that's what you need to do the carbon equation. And then also looking at 3 proxy points in the field where we're taking those other tests that farmers might do. So looking at soil structure, looking at worm count, biological activity. We're trying to gather all the previous management of those fields, so anything that's gone on those fields will come off those fields for the previous 5 years, so that we can start to look at what management work has an impact and what doesn't. And then also, as I say, that final stage in terms of the whole farm carbon footprint and what proportion of that is coming off in terms of soil carbon. Proxy tests that we're doing are soil structure, so how compacted it is and all those sort of things. We're looking at infiltration, so how much water the soil will hold. We're counting worms. It was also World Worm Week a couple of weeks ago, so we were out doing lots and lots of worm counts, looking at what was going on, not only in terms of numbers, but also what type of worm you had, so whether you had those deep burrowing worms that act like your cultivators and take, do all that sort of stuff. And aggregate stability, which is looking like a really important one, so how tightly bound together your soil particles are with glue. And then also we are burying underpants, so we are using the Soil My Undies test, because we were really keen to include something other than worm counts that was trying to look at biological activity, but some of the commercially available lab tests that you can do for biology aren't particularly reliable. So we thought this would be a good way to start. So you basically bury a pair of white cotton underpants and then you dig them up 3 months later and you see how much is left. And the theory is, if there's not very much left, then you've got a good biologically active soil. If they're still in one piece, then your soil is more dead. What we did find with the challenging conditions last summer is the fact that actually in fields where we thought there was lots and lots of biology, if they were impacted by the drought, so it sort of showed us that all living things need water. But it's something that we're replicating this year as well to see whether we can see a difference this year. And just to show you a few results, this is not really to sort of draw anything off it. So far, we haven't got all the results back in from year 1 yet, but this just shows the soil organic matter percentage of some of our farms. That blue line there is the 3% target that the government set in terms of that's where our soil should be in terms of their organic matter. So you can see from there, most of ours are above that. And in Cornwall, what we found is that actually soil organic matter is not the issue, it's compaction. So it's about that understanding, how do we keep hold of that organic matter and that carbon, but actually get our soils in better structural condition so that we can get more production of them. And that's something that we're trying to look at in year 2. But just to pull out a couple of bits, we've got the lowest sample from the southwest was 4.29%, so it's still above that 3%. And then, but there is a wide range across there. And just looking at some of those other proxy measures, you can see that across the different farming types, as you would expect, the sort of permanent pastures and the grasslands are better in terms of organic matter and sort of carbon yield. You've got sort of aggregate stability, so grassland, that's temporary grassland, was good for aggregate stability. Our arable fields were better for worms, but actually we were doing a lot of our Cornish samples are when it was very dry, so that's potentially been a bit thrown off. But lots more work to do, and we're continuing this all of this year. Then another project that we're working on here is the Diverse Forages project. So this is a SARIC funded project, working with the University of Reading, ourselves at Duchy College, Northwick, and then Cotswold Seeds. And this project is really looking to understand the benefits and how we can improve the resilience of our farming systems by using herbal leys. So trying to understand how we can use them. And interestingly, one of the things with this project is to look at the agronomic performance, so how they perform over different climatic conditions, because a lot of the work that's gone into herbal leys was done over in the east where it's dry. And the idea is that you can plant the deep rooting species within your grass mixes which go down and find the water. But when we started talking about Cornish conditions, up until last summer, we weren't really experiencing a lot of dry conditions. It was more how these species will cope in the wet. So one of the things that we're looking at under this is which of the species that do better in our usually more damp conditions, as opposed to the one sites over in Reading, where what they're really looking at is what stands up in drought. And as I say, we're looking, so we've got some replicated plot sites at Duchy and at Rothamsted, and then we've also got farmers who are growing these mixes under normal farm management conditions and looking at how they perform as well, of which Woodland Valley is one of them. And again, it's not really anything to get fixated about, but as I say, it's the agronomy package, so that's the bits that we're doing the replicated trials. And we're testing 4 mixes, so we've got ryegrass clover as the sort of control. We've got 2 very diverse mixes, so one that's got 13 species in it and one that's got 15, and then we've got one that was proved through a different research project looking at drought tolerance, which is being used as a sort of halfway house that has about 7 species in it. And as I I say, the bit that Chris is involved in here is this work package 3, so on-farm mixture evaluation, to look at how they stand up under sort of more traditional, under farm conditions rather than being pampered in a research project. And then finally, before I stop whittering, the other project that I'm involved in is the farm crap app. Have any of you heard of crap app? Yeah, fantastic. Okay, so I won't bore you too much about it. But just to give you a few stats, manure management in Cornwall, how much manure we have to deal with. 3.29 million tonnes from our dairy friends, 1.1 million tonnes from our beef cattle, and 1.1 million tonnes from our sheep. So that's a lot of manure that we have to manage in Cornwall. And we all know it's not a new phenomenon that good nutrient management is a win-win-win. It doesn't matter which metric you put nutrient management on, it will always win in terms of a good thing to be doing, environmentally, economically, greenhouse gas, water, any of them. If you can manage those nutrients and you can integrate fertilisers and the manures that you provide on farm together, then that's always going to be good. But we're also under a lot more environmental regulations going on now. We've got the new ammonia regs that are coming out, we've got farming for water regs. So we've got to work out how we deal with all of our manures. And in Cornwall, we have a big issue with storage and all these other things. So it's quite a complicated issue. And when we looked at this a few years ago, we found that there were quite a few tools out there that you could use, but they were underutilised, and there were a lot of people that weren't using these tools. And thus the Farm Crap App was born. And as I say, it was first made a few years ago, to determine crop available nitrate, phosphate and potash values of different slurries and manures based on different application rates. It was designed to be input only, so only what was going on in terms of that manure. And we developed it to be used in the field, so it doesn't need any mobile phone signal or Wi-Fi to work. Once it's on your phone, it's there. So we know that connectivity can sometimes be a bit of an issue. And that went really well, and we took it out and we showed it to industry, and they said, yeah, we really like this, it's simple, but it would be really good if it did this, or if it did this. And so we thought, well, actually, this has been a really good thing to do, but actually we really want to act on some of these things that people say, yeah, I really like it, and it would be even better and I could use it more if it did this and this. So we're now on Farm Crap App Pro, which is the new version. It's still free. You don't have to pay to use it. It's still available. It's available on Apple or Android. Still don't need signal or Wi-Fi. The new version has all the new RB209 figures in it. So RB209 was updated a couple of years ago now. All those information is in there, and as and when AHDB put anything new into RB209, that will seamlessly feed into the new app. And it now has full crop records in it. It still has that calculator, so quick screen what's going on in this application, or you can set up all your field records. And at the current stage we're at the moment, we are testing with users before we launch. That's the scary bit. But we're taking it out and showing it to farmers, advisors, anyone else to say, what do you think? Is it fit for purpose before we launch? And as I say, if anybody is interested in having a look at it, or having a play with it, or wanting to talk about how to get involved, please let me know. I would be really, really happy for as many people to look at it and tell me what's wrong with it at this point, because when we can do something about it. But the idea really is to provide something that is genuinely useful rather than another tool. So please use it and tell us what you think. And as I say, it's just trying to get things that work for farmers. And I think that's it. Thank you very much. Anybody, as I say, I have got to scoot off, but if anybody has got any questions, please through Becky or just ping me an email and I'll be happy to talk to you about it.
Yeah, we'll circulate your email